Well, as promised by people, we will be going through 2 lessons. First, we just looked at direct variation, and now we're looking at slope-intercept form. We also like to say that that's y equals mx plus b. So slope-intercept form, we've been looking at what an x-intercept is, what a y-intercept is, and we've been looking at slope. What we're finding is that if we have the slope and a good point, like an intercept, we can graph any line, right? So if I'm given the slope of 2 and a point, and let's just say it's the y-intercept of -3, then I can graph this whole line, right? I start with the y-intercept at 3, and then my slope is 2, which is also known as 2 over 1, because that's what any whole number can be made into a fraction over 1. So I know I'll be rising 2 and running 1. So I go from my -3 and I go up 2 over 1, up 2 over 1, up 2 over 1, and I can even choose to go down 2 and over a -1 as well, right? Let's try it again. If I'm given the slope of -3/4 and a y-intercept of -4, I find on the y-axis -4, and then I do my slope. Now I have to apply my negative to either 3 or 4. If I do it this way, it's going to go down 3 and over a +4, right? Or if I choose to apply it to the 4 instead, saying that my slope is 3 over -4, well then I'll be going up 3 and -4, right? All right. So when we do this, when we have a point, a good point like an intercept, and a slope, we can graph everything. But if we are using the y-intercept, we call this the slope-intercept form, or y equals mx plus b, where m is our slope, and the y-intercept is when x is 0, right? So for example, on y equals 2x plus 4, my slope is 2, not 2x, just 2, and my y-intercept is 4, right? And don't forget that all these other points of this x over here is every x on the graph, and this y represents every y on the graph. So, for example, if I graph this equation in slope-intercept form, y equals -3x minus 2, I first start with my y-intercept of -2, put that on my graph, and then my slope is -3, which is -3 over 1. So I could go down 3 over 1, but I could also choose to have it be 3 over -1, going up 3 and over a -1, right? Then I draw my line using a straight edge, of course, always. If I have this equation of the line, y equals 1/3 x plus 3, my y-intercept is 3, and I start there at 3. And then my slope is up 1 and over 3. You try. Please graph the equation. That's right. You start on -1 and you go down 3 and over a -4, or I could have gone up 3 and over a +4, right? 3 and a +4. This is the usual way to do it, but I did want to remind you that you can also go negative and negative. Okay, go ahead and write an equation in slope-intercept form if you are given a slope and an intercept, right? If you're given these, then you can write the equation of the line. Y equals, our slope is 5/2, and our y-intercept is -6. So we're going to change that to -6. Go ahead and try writing this equation. Pause the video and check your solution. Hopefully, you also got y equals -6x plus 3. Now we're writing the equation of a graph in slope-intercept form. So if they've given me a line, there's a couple of ways I can do this, but I can just look at it visually. I can see that my y-intercept is 3, and my slope is 3/2. So I'm either, if I go from the bottom point, I go up 3 and over a +2, or if I start at the top and I go down 3 and over -2, then it's still either -3 over -2, which is 3/2, doesn't matter. So inside the slope and the y-intercept, I go ahead and write the equation of my line. And notice that my slope is positive, right? This is positive, and the visual of this line is definitely positive, right? It ends up in the positive quadrant. So how can I convert from standard form to y-intercept form? Well, if I'm just given this, right, I could choose to use my x and y intercepts because I'm in standard form. But what's the problem with that? If I went ahead and used my x and y intercepts, right, which I'm pretty confident to do, if I want to solve for y, that's when x is 0. So then I'd get -2. Y equals 8, and I would divide, and I'd get -4, which is great. But then when I went to solve for my x value, when y is 0, then I have a bit of a problem, because then I'm going to end up with 3x equals 8. And now I end up with a fraction of 8/3 for my x-intercept. Where am I supposed to put that? Is that right here? Question mark? I don't know. So we don't want to do that. We don't want to use x and y intercepts for something like this. And it makes sense, right? So how do I solve for this? Well, I go ahead and solve for y. So I'm going to subtract 3x from both sides. And I'm going to go ahead and divide off a -2. Giving me y equals 3/2x minus 4. Now I can graph this very simply. This is, again, why fractions are our friends and they're nothing to be scared about. I start and I have -4, and then I go with my y-intercept, then I go up 3 and over 2, up 3 and over 2, right? I'm just going up 3 right here and over 2, up 3 and over 2. Go ahead and give this one a whirl. Pause the video and then check your solutions. Okay, so now on this one, honestly, I would just use x and y intercepts because it's so much faster. But if I go ahead and solve this way, I'd get my +5, and I'd go down 3 and over 1, down 3 and over 1, down 3 and over 1, and check it. But I could have done x and y intercepts as well, right? Because it would work out very easily with this one. When x is 0, y is going to be 5. And when y is 0, x is going to be, oh, you're right, 10/6. I don't want to do that. I'm going to go ahead and stop here because that's not always the same homework I want to do. Alrighty, have a great day. Make sure you check Moodle for your homework if you're at home.